Welcome you all. In this session, we are going to discuss in detail about the temperature rise in transformer. So, what are the cause and effects and how it can be controlled in case of transformer. The temperature rise in transformer. So, the temperature is mainly due to losses. So, now the losses dissipated in transformer in core and winding get converted into thermal energy and cause heating of corresponding transformer parts. The heat dissipation occurs as follows. From the internal heat parts to the outer surface, so we call them as conduction. From oil of tank walls by conversion. From walls of tank to the atmosphere by convection. So the heat transfers in the form of conduction, conversion and radiation. So these are the three forms how the heat energy is transformed from various parts of transformer. So the notations we use are Q, the power loss in terms of joules or watts, G, weight of active material of machine in kilogram, and H, specific heat in joules per kg degree Celsius, S, cooling surface area, and lambda, specific heat dissipation, C, 1 by lambda, which is the cooling coefficient, and theta m is the final steady state temperature rise. Final steady state temperature rise of transformer. The temperature of machine rises when it is supplying to load. As the temperature rises, the heat dissipated parts by conduction, partly by radiation, and most of the case largely by air cooling. So the temperature rise curve is exponentially in nature. Assuming the theory of heating of homogeneous bodies, heat developed is equal to heat stored plus heat dissipated. Heat stored plus heat dissipated. So now how to design the cooling tubes for transformer in order to cool down the transformer. So the dimensions of transformer, the dimensions of tank depends on the type and capacity of transformer. Type and capacity of transformer. Voltage rating and electrical clearance to be provided between the transformer and tank clearance to accommodate the connections and tanks. Clearance for base and oil above the transformer, etc. The clearance are assumed to be 30 to 16 centimeter with respect to tank height, 10 to 20 centimeter with respect to tank length, and 10 to 20 centimeter with respect to tank width or breadth. So this is the dimension of transformer tank. Here you can see the core and where D represents the distance between two adjacent limbs, H represents the height of tank, and C1, C2, C3, these values are the clearance value. Tank height HT, H is nothing but the tank height, which is equal to HW plus 2HY or 2A. The clearance of 30 to 60 centimeter for single and three phase shell type transformer. 3 into HW plus 2Y. This is for three phase shell type transformer. If it is three phase core type or single phase shell type, the first formula. For three phase means you need to multiply, for three phase shell type alone you need to multiply it by 3. Next form expression is to calculate the tank length. The tank length LT is equal to D. D represents the distance between two adjacent limbs plus D extension plus the clearance value for single phase core type transformer. 2D times for three phase core type and 4A plus 2WW for a single and three phase shell type transformer. So you can easily remember this D, 2D, and it is 4. It goes in this fashion. And for you don't forget that for single line 3 phase it is 4A plus 2WW plus clearance value. Width or breadth of tank. The width is given by d extent plus clearance value for all types of transformer with circular coil. If it is a rectangular coil, core type rectangular coil for both single line 3 phase, the formula to calculate width is B plus WW plus clearance value. And for single line 3 phase shell type transformer, WT is equal to B plus 2WW plus clearance. B plus 2WW plus clearance. The effective surface area of tank ST for which heat is getting dissipated can be assumed to be 2HT LT plus WT meter square. At final steady temperature rise condition, losses is equal to 12.5 ST plus 8.78 AT. If dt is the diameter of tube, then the dissipating area of each tube at pdx into 0.9 ht. If nt is the number of tubes and at is equal to small at into nt. Thank you.